Have you ever tried to make an image with just channel information? Chops? Do you know what channel information is? So what you're looking at is my first attempt at making video synthesis in TouchDesigner. Today I would like to teach you how I made this. We're not going to make this whole thing. We're going to get to this part. We're going to make the output. And so what I mean by video synthesis is we're just generating values between 0 and 1 or higher, combining these different waveforms. We can use a pattern, we can use waves, you could use audio. We're going to use math functions like adding, subtracting, multiplying to create these up and down interesting little squigglies and then manipulate them in some interesting ways and get something like this. Oh, my computer's not too happy. Well, yours will run better without a UI. Yeah, and the only difference will be I've got some fancy controls for mine. Let's get into it. And you should be able to do this in any version. We're not using pops. This is channel, your most classic tops. So just, have a little bit of understanding about how to make nodes and connect wires, and I should be able to help you with the rest. What this whole wave warp system is built around is not the warp chop, but the wave chop, which is kind of like an LFO. With LFOs, audio, you have 0 as kind of your center, and you're going down to -1, up to 1 at a baseline. And then you notice we have types, and all of these have different shapes. And period, kind of like if you're ever trying to control noise, we can raise this so you're just seeing 2 repeating patterns. You can play with this. Amplitude is going to be how high and low it goes. There's a square wave. And believe it or not, we're going to use this to just make pixels on a screen. And in pixel world, anything below 0 is going to be black. Anything hitting 1 is going to be red or green or blue. Or if you have 3 channels, which we're going to make, and the red and the green and the blue are all at 1, well, then that's going to draw a white pixel. And that's kind of it. We're going to focus on the wave type, the period, the phase, which will animate. The bias is optional. You can kind of draw a little bit different shapes within the wave, and the amplitude. Set that to 1, and then it peaks at 1. We have most of what we need just with this one node. But to animate it, let's just grab a constant chop, and we'll plug that into a speed. Set to loop 0 to 1. And now when we change this value, you can see that depending on how high this is, the speed will loop at different times. Make this viewer active here, and we'll put that on the phase. And this should just seamlessly loop 0 to 1. Okay. And then we just need to do this 3 more times. So you can copy and paste those, and we need new references because we want independent phases for each of these. So we have different control points. We can make this one faster, and this one can be really slow. 0.05, just crawling. And now we can change these different wave types. I say change everything. I'll have a square, a triangle, and a sine wave. And then we put all of those into a merge. And that's going to be our red, green, and blue. Look at that. And now if you middle click on this, it's telling you there's 3 channels, and it goes from 0 to 299 or 1 to 300. And there's ways of stretching this, manipulating it. We will do more interesting things between the waves and the merge, but just so you can quickly see how this works. All of our pixel information is going to be generated in chops, but then to make it into pixels, we use the CHOPtoTOP. Look at that. You notice that the data format says R. We want RGB. And believe it or not, like this is, look at that. You can right click and view. And this is all we're making here. Not very exciting, is it? One thin row of pixels. Now, if you middle mouse click on this, you'll see the size is 300 by 1. So 300 pixels across, 1 pixel up and down. You could get more pixels if you do these rows per channel set wrapped. You click that, it doesn't do anything. Well, you can go in the common tab and make a custom resolution. And so instead of 300, we could do 150 by 2 pixels. And now it's still animating those, but after 150 pixels, it just wraps the next ones a line down. Now that's a way where you can make your base pixels that we're using, you can make them thicker with more kind of variation in layers and texture. Why? Oh my God. Now another thing by default, you'll middle mouse click and get information about any of these operators, but you'll see the format is 32-bit float. The pixels are going to be on your screen, they're going to be 8-bit for the most part. But what this means is like if we are adding waves together and it goes above 1, 1 plus 1, 2, so it's going above that, well, it might not just, it's not going to display colors above white or red or whatever, but you can use, there's more detail of information and there's more fidelity in the values rather than just stopping at 1 or 0, which can come in handy. It won't matter that much for what we're doing today, but just so you know, it also is computationally a lot more expensive, but you know, for 300 pixels, not that big a deal. So sorry if this is slow. This is we've got some wave chops, a merge, chop 2, and the speeds to animate it. Let's see. Okay, we're not ready to connect anything out of that. In my workflow, I take a constant, and I'm going to use this, drop the alpha to 0. In the common tab, let's set what we want for our feedback resolution. I'm just going to do 1,000 by 1,000 because that'll work for all of you. And then we're going to composite these together. So I think the first input is going to be this. So composite. We'll take that from the chop to top and it'll be like, okay, that looks the same. But when we plug this constant top in and set the operation to over, well, now we've stretched the whole thing over 1,000 pixels by 1,000 pixels. We're getting tons of pixels out of that, but transform tab, we don't want to fill. Let's use native resolution. And now we just got the little thing in the middle of this. You can go crazy with the scale. You can in either direction. But we don't want to fill the whole thing because the feedback is going to take care of all that empty space. One thing we want to look at is the justify. You know, it might make more sense to have it on the bottom or the top and have it propagate outwards or from the middle. And so justify, that's kind of an important parameter. I suppose you could rotate it here. I don't know if I've ever played with that. It might be a good control point. Set your scale and whatever to whatever. But this is kind of your way of like stretching it before we start doing anything real wacky. But from there, then we start our feedback loop. So grab a feedback top. Won't do anything until we close the loop, but we will need a level in there. And let's see, transform. and then one more composite. And we will set this to over again. Let's see. I'm going to make sure that is on the top. Transform on the bottom, and then we drag the composite onto the feedback. And now, well, it's just holding in place. But now once we rotate and scale, this is nothing super fancy, but this gives you some things to start playing with. I like to do my translates in pixels. So if you want to move it up and down, and it's like, oh, it's going off screen. Well, I would suggest going over to the tile page and picking either repeat or mirror. And did we just lock up? What the hell? What the hell? What the hell are you doing down here? Okay, I got to get the cat upstairs. All right, so this transform is a pretty important piece of this. And you might want to try playing around with the order, whether it rotates first or if you scale it first. That's a little bit aggressive. I'm going to do -6. And, you know, that's all fine and dandy, but what if we stuck a displacement in here? And for this second source, we just take our waveform data and plug it in here. Now this is basically completely destroyed, but let's bring the weight down to 0 and just ease it up a little bit. And maybe ease it down a little bit. And even that is looking kind of cool. If we go back and look at this level, I mostly have mine to play with the opacity a little bit, so it has a chance to kind of dissolve. If this is at 1, it will just kind of hold and fill, bring it down just a little bit. It won't just blow out in solid color. Okay, from this composite here, let's do another transform. And this time let's set the resolution to custom. This is where you would make it whatever you want it to actually be in the output, and then the output aspect, have that be resolution. And now, let's go to our tile, and I'm going to do repeat on this again. And now here's another place where we can scale. And see, now if I bring the scale down, we get repeating patterns. And you scale it up, you get this. And this is where I really like the rotate before the scale. Because you can get, if you don't do that, it's just going to, evenly twist all of these. But if you have it set to rotate, scale, translate, you get some weird, stretching. And you can go really low and start making dense patterns. The whole reason I made my UI is because now we've got these kind of interesting controls, but they're all over the place. And what I have in my network is another displacement. And I have a switch going from the chop to and the feedback output. And then we plug that into this displacement. Now that is, once again, we're fully on. And if you don't know how a displacement works, it's basically more pixel math. Like earlier in the process, we're going to be doing chop math to generate these waves and then into pixels. But now we can do a different kind of math where, depending on the input source, you're using pixels in the second input to instruct where to relocate basically the initial pixels in the first input. So let's see if I can get this on screen. It's essentially going to stretch all of this, but let's see if we can get... So we have just the red channel for the horizontal. So if I start pushing that up just a little bit, this thin strip of pixels is going to be stretching to the whole image, and every time the red goes by, it's going to be displacing basically everything. So that might be a reason to use something else there. Oh my God. It's like 2 screens wide. So yeah, if we switch these inputs, so now we're looking at it from the feedback. And since the red isn't going to be covering the screen at any point, it'll get a little less intense and a little more varied. And right now we have the vertical source being blue. We'll switch that to green and give that some upward push where the green is. And since we have this in 32-bit flow, this is one area where, okay, so these values, maybe the pixels are only going to be displayed 0 to 1, black to white, but the information in this chop to top, it can be going below 0. And in this case, that can be used to push, kind of push and pull in both directions. And so this is where we can start getting some sort of like drippy looking stuff. And honestly, this is most of it. That is very close to the basic guts of this process. And obviously I'm doing way more than that. One thing I'm doing is I have an optional pattern chop I can put in here. We're just going to plug it right in the mix. And it's like, okay, well, that just overtook what we have. Well, on the channel tab, we can do combine channels. We can do add, or we can do multiply. And that is going to be basic math on the channels, where it's like the square wave is either 1 or 0, on or off. And we have a sine wave. Here, I'll have a copy of it. 1 times 0 is 0. And that's how you would get these big dips in here. And we can do that on all of these. We'll do another pattern. We'll set this one to ramp and number of cycles. That's kind of our period. Give it a bunch. And I also like this taper. You can kind of get a ramp in the pattern. And then we'll make this one add. Look at that. And we'll do one more down here. Pattern. And this time we'll do a square. Tons. Let's do 20 cycles. Tight up and down. And we can multiply this one. Look at that. That's cool. So now you see this channel information is very different than what we were making before. And even though we're bending it and stretching it and displacing it all over the place, it's based off of this. This is where all that is coming from. And you can do all the same things. I'm going to just grab some of these phases and so that they're moving in different times. Which one did I slow this one down? You need a phase. Slow this one down. Let's slow these all down a little bit. I wasn't content with just mashing 2 waves together, but I mean, this is enough. My process has switches. So basically everything coming out of these waves gets a switch. So there's all three going into this one, and then we'll have another one. So we can switch. This one's 0, input 0. This one's input 1. Now we can use a math chop and combine the channels, or combine the chops with all these different types, like an average of the two, the minimum of the two. We can subtract them. We can add them. We can multiply. I would be hesitant to divide, since it'll look more like that. Good for really breaking the look of things as it goes to negative 2000. But yeah, I don't think length will help you. But here's all these other ways. So I will put this in the first input. Let's make some more room here. You can color nodes really easily. Just hit C, it pops up these little windows. So I could take that. Let's make this one, this group green. One more time. Make this group blue. And oops. We just need the switches output. Okay. So I made copies. They're all the same. This is another good little lesson. This is visualizing very well how the pixel math works, because it's either black or white. All of our three channels are coming together. You can see how this channel information is translating into pixels, because we're just looking at one source. But that's not too fun. Let's make this one 2 and this one 0, and let's average. And then let's switch this one to 1 and this one to 2, and we'll do multiply. Now we have these going in as our chops. And I suppose the other thing, I'm not going to fully demonstrate, but use LFOs, especially if you don't build a UI and you're not having the controls easily. You can kind of keep everything animated by using LFOs. And the LFO chop is built for just that. So we could, frequency, let's do 0.1. Let's use a math to rescale the range. So we'll just match it in here. -1 to 1, and we want 0 to 0.5. And let's put this on the amplitude. We could do another one. Let's drop the frequency even more. And for this one, we'll go, let's play with the period. Let's just say 1 to 3 or something. 1, 2, 3. And you can do this all over. And now we're kind of getting movement no matter what's happening, but remember you have controls on this composite, and this is another good reason to have shut up. It's another good reason to have colors available. So I like to use yellow or orange for my different control points. So here, and yeah, opacity. But yeah, this transform. We're not doing anything here, but this is another place. So the kind of video synthesis part is mostly happening, where we're generating it in chops, and then you can just use whatever. You can use all the different TouchDesigner top techniques to play with it. This was just my first experiment. I keep finding things to do with it from here. This transform is a really big one. And you can always mirror if you like that. You know, translating it doesn't do that much when you've got things scaled so aggressively, but yeah, you know, like one really small scale and one big one is kind of an interesting look. And here the rotation starts making the repeating patterns offset, which I like. Both of them being kind of larger can look good. This is the guts of how I built my component. Which is to say, like, obviously this doesn't take too long. But what does take long is making a UI that's, it's not modular, but to depict and demystify this workflow and just make convenience. I spent a lot of time making it ready for MIDI. So yeah, if you like this, you might want to check out what I ended up building with this little visual experiment that suddenly spilled into months of obsession, I guess. But yeah, it's fun. And so, okay, the original resolution was 3:1. I made mine, you know, if you take an info from any of your chops, info, you can grab the length. And you can use, I'm getting pretty good about not using constants, but since we're not building a menu, say we want 3 rows. We can use this, just call it rows. ROAs. Good old math chop. We can combine these chops with a divide, and bam. Now we can have 3 rows at 100 pixels. Now you see there's 3 rows, and that will change the look, and that will change how this looks. But all these variables have crazy effects on it. If I go back down to scale of 3, now we barely see this. Maybe I want to stretch it lengthwise all the way. Let's give it 4 rows. And let's transform. Let's go big here. Drop the rotation down. Scale it in. Let's bring the Y scale up. Let's bring the X way down. Now what happens when we rotate it? Yeah, it's kind of crude. Is this also where we were setting our output resolution? I'm going to do 1280 by 1280. Yeah, and there's a whole other thing about getting more resolution from your waves or your patterns. One thing that's not intuitive, and I don't really know how to account for, but the frame rate changes the resolution. So I go up to 60 frames here. You can't see the bottom of my TouchDesigner, but I just set it to 60 frames. And now all of a sudden, the samples of this go from 0 to 599. So we just upped the resolution of this. But since we're using this dynamic math system, it knew to change the rows. If I drop or change the length of each row. If I go back down to 1, yeah, the length is 600 instead of 300. If I go to 2, Now it's 2 rows of 300. So there's just all these little moving parts, and they all end up having a pretty significant effect. What if I change the horizontal to green? What if we go more aggressive with that? Oops. You want to do really little, you want to do little movements with the displacement. But yeah. Yeah, I mean, for something so dumb and simple, like I'll never be done finding weird combinations. Like this is a new one for me. And so yeah, it's an experimental process meant for just exploring with pretty simple techniques. But I've never tried drawing graphics on a screen with just raw channel information. So I thought this was fun. I hope you enjoy it, and I hope you check out the tool that I've been working on for months, which I'm going to do a new overview, and if you've made it this far, you will see what I made and be like, oh, this is for that, this is for that, and I hope you find it interesting. And what would be the coolest is if you took this and had some crazy ideas that I never would have thought of. Take it from here, take it from there, and please let me know. Please show me that. Whatever you just thought of that I didn't think of, that's cool. Thank you for your time and patience. And okay, you know what? Let's just look at this real quick. There's a million little things under the hood that I'm not going to get into, but let's look at everything. So here's all my different LFOs, and I just have 6 of them that you can set. Basically, this window down here controls LFOs, and you can pick the different types. So I have 6 of them, and then I can reference them all over basically all the relevant parameters. And this whole first wave tab is what you're seeing is like the square wave, all these different types. And then I also have, here's for the pattern that we made. We added the pattern later, and I can turn that on and off, choose like to add or multiply, pattern type, and then the direction it moves. These are all things that we built. I just have a fancy looking version of it. And the same thing here. This is like, we have the 3 waves, and we can choose the different types and what kind of math operations we want to do from them. Let's multiply. Oh, I don't want to have it be that complicated. These are my little bypass knobs. So if I turn all of this off, now we're down to just the basic wave chops being output. But they're all being animated because I have LFOs everywhere. I didn't get into this. This is just like using a cache on the thin little CHOPtoTOP that we made, doing some compositing before it goes in the feedback loop. Can make it a little more interesting, make it glitchy. But this feedback, that's our composite top we did. The rows, that's that math that little rows plus the length math we did. And then this is controlling the canvas size before it goes in the feedback loop. Thick is just, I think, basically just a scale parameter. And here's the opacity for our feedback. And then you've got your translate. And you notice I have LFOs for all these. You can turn them on or off. We've got our first displacement. That's the one in the feedback loop. And then we have our scale and rotate. That's that transform. And then another feedback with the switch for the source. And then it goes out. The one thing we didn't get into is how you can color this after the fact. We didn't really do any post-processing, but that's pretty straightforward. I mean, just throw a bloom on the end of it and call it a day. You'll be perfectly good. But I made this little lookup table where I can kind of, I'll pick this dark green and a light purple. A light purple? Yeah. And saturate, contrast. So it's just level controls and a HSV adjust, and then I added, some brightness, black level, just some basic controls, help you dial in the look, and then I can turn that on and off. You can kind of blend in the original color with the new color. Simple, but effective. That's kind of all I've been going for here. I promise you're not missing much except for an easy user experience, right? So you can build this on your own. It'll take a lot longer than the tutorial, or you can support me and pick this up. I'll probably still get ideas. I'll probably keep updating it. I mean, I thought I was done, and now we're on 1.6. So that's stages of like, oh, but what if I did this? What if I did this? What if I did this? But please, take this knowledge, do something cool with it, or just whatever. I hope you learned something. I hope this was fun. That's how I say goodbye now.